Hello everyone, welcome back. So let's talk about polynomial regression function. So we have discussed your simple regression function, we have discussed your multiple regression function. So what is polynomial regression function? So it's a bit different from the functions we have seen in the previous videos. So let's see how it is. So it's very simple also. So there's no or there won't be any issue in understanding it. So this is yi. Then this is a model which is of the form yi equal to beta naught plus beta 1 xi plus beta 2 xi squared ui. So this is a second degree polynomial regression function. So degree, how is this being measured? Is basically measured by the power of the x variable. So to what highest power your x variable is there in the model, that tells us the degree of the polynomial regression function. So poly means multiple degrees. So there's a single variable, single explanatory variable, explanatory variable. So we have a single explanatory variable which is in different powers. Okay, that is why it's called a polynomial regression function, right? And why is it studied under multiple regression function? Because we get a model like this. So we have multiple regressors of the same explanatory variable but in different powers. So we have studied in the case of multiple regression function that your uh, regressors can be non-linear, right? They can have a different function which is not linear, and uh, the only thing that is required is the function should be linear in your parameters. So this function is also linear in parameters, but it is not linear in your xi variables. Okay, and that is why it is a special form of a multiple regression function, and it's called the polynomial regression function, right? So this is a polynomial regression function of kth degree because the maximum power of the xi variable is k, right? So let's see an example of a polynomial regression function. So suppose there's a function of this form. So this is basically your marginal cost function. You must have uh, studied this in your microeconomics. So if I use this function and I plot it on the graph, this is how it looks like. You know this graph. This is the graph of your marginal cost. Okay. So this is how it is used. This function is used in such situation. Uh, it is used to estimate the functions that we have studied, which might be following a polynomial variable, right? So parameters estimated by OLS are linear in parameters, or the estimators estimated. So we know this. This is already known that the parameters are linear. Okay, the regressors might be non-linear, but your coefficients or the parameters are linear, right? The xi variable are non-linearly correlated, therefore no multi-collinearity. So in this model, there is no problem of multi-collinearity. So this is basically talking about uh, the properties, right? How both the properties are satisfied because it is linear in parameter, and xi variables are non-linearly correlated because I have non-linear variables, right? Xi square, etc. So there might be a linear relationship. There can't be a collinear relationship because they are not linear, right? So they can have a non-linear relationship, which is not an issue for the model. We have discussed this, and therefore there will not be a problem of multi-collinearity. So if you can go back and see what multi-collinearity is, I've explained this in the previous videos, you will understand more exactly what this means. So this is sorry, this is all for this video. I hope this was clear, and we'll meet again in the next video soon. Till then, take care.